In this video, let's take a look at how to convert from base 10 to other bases. So we'll first take a look at the theoretical aspect, and then we'll learn how to implement this in Python. So let's say we have a number, we have 429, and we want to convert this from base 10 into base 7. Well, our result is going to be 1152 in base 7. But how do we actually go about producing that number? So it helps if we create a table for this, because the way we're going to do this requires that we do a lot of division and modular arithmetic. So I'm first going to set up a few rows here, and I'll just label them just for your reference. So we'll first start off with powers of 7. And I'll explain all of these after I write them down. So we have powers of 7 that we're going to use. We're going to have to refer to our current number. And then we're going to have a division expression. So division expression. And then we're going to have a quotient from our division. So we'll just divide two numbers. And then we'll find the remainder of that division. Alright, so now that we've written all this, let's explain what each of these mean. So with the powers of 7, what we're going to do is we're going to keep dividing any particular number by the largest power of 7 that is less than that number. So for example, if we're starting with 429, we're going to divide that by the largest power of 7 that's below it. So that's going to be 7 to the power of 3, which is 343. And once we divide that, we will get a certain quotient. And that quotient is going to be the digit for that place value. And then the remainder we get is going to be divided by the next largest power of 7 that's below it, which is going to be, in this case, 7 squared, which is 49. And then we'll divide by 7 to the 1, which is 7, and then we'll just divide by 7 to the 0, which is 1. So let's just break this out into columns. So we'll have 7 to the power of 3 is equal to 343, because that's the largest power of 7 that's below 429. And then we're going to have 7 squared, which is equal to 49. And then we'll have 7 to the power of 1, which is equal to 7. And then we'll have 7 to the power of 0, which is equal to 1. So let's just break these into columns here. Alright, so let's start with the process. So our current number is going to be 429. Now our division expression, we're going to do 429 divided by 343. And what do we get when we divide 429 by 343? Well, our quotient is going to be 1. And then when we take the remainder of that, that's just going to be 429 minus 343 in this case, just because our quotient was 1. So that remainder is going to be 86. And now that we have this 86, we're going to set this as our new current number. So we'll move this up here. And now this is 86. And now we're going to divide 86 by 49. And 86 divided by 49, again, that only goes in once, so our quotient is 1. And our remainder is going to be 86 minus 49, which is 37. And then we bring 37 up to our current number in the next iteration. And now we're dividing 37 divided by 7. And 37 divided by 7 is going to give a quotient of 5 with a remainder of 2. Because that's just 5 times 7 is 35, plus 2 is 37. And finally, we bring this 2 up here, and we have a 2. And we take 2 divided by 1, and we get a quotient of 2, and our remainder is 0. And if you take the digits that are under a quotient, we're going to find that it's 1, 1, 5, 2. And this was the exact number we're looking for, so 1152 in base 7. And another thing you should notice is that this last remainder here, it's always going to be equal to 0. So when you're doing this, if it's not equal to 0, then that means there's something that went wrong in your calculations. So this process is always going to work, and it even works if you're converting from base 10 to bases that are greater than 10. So for example, if you're converting from base 10 to base 16, you're going to have a few additional digits, which are going to be A, B, C, D, E, and F. Well, how would we actually account for those letters? Each of those letters is going to be assigned to a number. It's just going to be the number that's after 10. So A is going to be assigned to 11, B is going to be assigned to 12, C is to 13, D is to 14, E is to 15, and f is to 16. And then the process works the same. So whenever we see a quotient of 15, we're going to put an f for that. And if we see a quotient of maybe 11, that's going to be a b. So it's pretty straightforward like that. Let's go ahead and implement this in code. We can start here by declaring our function. Let's call it convert from base 10. So def convert from base 10. And then we're going to have two parameters. Our first one's going to be num, and that's going to be the number that we're converting. And then we're going to have base. So that's going to represent the base that we're converting to. Now inside this, we need to create our conversion dictionary. So the reason we're doing this is because we're going to return a string eventually that represents our number in a different base. And our string could potentially contain characters because we could be converting to a base that's greater than 10. So here we'll just say create conversion dictionary. So our first step will be num2car. So this is going to be a variable that represents the dictionary containing all our characters. So we're going to say I is to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then A, B, C, D, E, F. And we're just going to index this at I. And then we'll say for I in range 16. So what does this mean? Well, this is actually just a form of list comprehension, except it's for dictionaries. So we create a loop inside a dictionary, and for every I in range 16 like we have here, that's just going to represent all the numbers from 0 to 15, and we just map that integer to its respective character. So 0 will map to 0, 1 will map to 1, all the way to 9 will map to 9, but then 10 will map to A, 11 will map to B, and so on and so forth until we get 15 maps to F. And so that makes it much easier to actually return a proper string that contains our number in a new base. So now that we have this, we need to configure our largest power. So we need to get the largest power of our base that is less than our number. So we can easily do this with logarithms. So here we're going to set power to largest. So in order to do this, we need to import log from the math class or from the math module. So we'll say from math import log. And here we can say power is equal to log, and then our number is going to be num and our base is base. So if we were working in base 7, we would take log 7 of num. And we just want to convert this to an integer because we want an integer power. So int that, and that'll just scale it down to the largest integer that is below this logarithm. Now once we have this, we actually need to convert the number. So that'll be convert number. And in this step, we start off with an empty string. We'll call that converted is equal to empty string. And then we need to do a loop. So for pow in range, and we're going to go backwards starting from power. So we'll start power, and we need to include 0 as one of our iterations. So we'll go to -1 and then -1. So that allows us to decrease in our iterator. And inside this loop, we need to first divide, and then we need to find the remainder. So in our division, we can say converted plus equals num2car. And then the number that we're converting is going to be the result of floor dividing num by base to the power of pow. So that'll just get us that integer result. And then the remainder that we get is going to be assigned to the new num. So we're going to say num mod equals base to the power of pow. And we don't need the space here. So this will keep dividing the number by the base to the power of the next power that's available. It'll assign that respective character to whatever new position in our converted number, and then we'll just change our original number so that we can proceed to our next iteration. Now finally, once we have this, we can just return. So we'll say return converted, and that's it for this program. Let's go ahead and test out our code. So we'll say print, and let's say we want to convert from base 10. We want to convert 429 into base 7, because that's the example we worked with before. And if this works correctly, we should get 1152 in base 7. So let's run this, and we get 1152. So it looks like it worked. Now let's try a few more examples. Let's say I print convert from base 10, and I want to do 18238 and 7, or maybe not 7, let's do base 16 maybe. And so let's run this, and we should get 473E. And so this shows that it still works for converting from base 10 to bases that are greater than base 10. So that's it for this video, and I hope this was helpful.